Welcome back, class. This is your Catia mentor, and in this video we're going to learn how to create an assembly. So we'll create an assembly of a lunar lander, learn how to insert components and parts. But let me first start by showing you a kinematic simulation. So let's go ahead and let's take off. Let's lose the first stage. And let's zoom into our second stage. And let's go ahead and open up the nose. Okay, so there's our payload, the lunar lander. Notice it has a blue interface ring that attaches to the cone of the rocket. What I'm not showing here is a belt clamp that goes around that holds it in place. So once we're ready to unload the payload, this belt would be triggered to come off. And it's something similar to what you see in a car exhaust system. If you've ever replaced a muffler on a car, it's similar to a muffler clamp. Alright, so let's get started. We're going to go ahead and create an assembly. So let's go into the assembly design app, and we're going to insert a 3D part in blue. There's also a 3D shape, which I'll explain in a minute. Actually, you know what? Let's go ahead and insert a 3D shape now. You have to point, you have to click on where you want to insert it. There it is. And typically something like this, a shape, a 3D shape is typically to keep some geometry. It can be an axis, it can be important planes, or a surface of a vehicle, or a surface of a wing of a plane, or fuselage surface. So this would you would keep those important components. So I'm going to insert an axis. There it is, at 0, 0, 0, which I'll use in a minute. Okay, so now let's go ahead and insert. So I'm going to double click on assembly, and we can insert a 3D part. Click on it. Right, we already had selected the assembly, so it loads the 3D part. So what's the difference between a 3D shape and a 3D part? Okay, so imagine the assembly as a binder. Okay, so imagine your assembly as a binder. Imagine a 3D shape as a sheet of paper. So on this one, we have a 3D shape piece of paper with a sheet protector. Okay, so typically when you're designing parts, you want that sheet protector. The ones without a sheet protector, that's where you typically have some type of reference geometry, planes, uh, axes, for example. Maybe if it's an aircraft, it can be the aircraft coordinate system axis, etc. All right, so but when you're designing parts, you want to insert 3D parts, sheet protector with the sheet inside, right? So it automatically generates the sheet. Okay, so this one, we're going to label it as floor. Okay, so we're going to create the floor of the lander. Okay, so if we're ready to design, double click on the sheet of paper so we can start drawing on it. So let's create a sketch on the XY plane. Create a polygon, hexagon, and we'll just round off the dimensions. Because of time, I'm going to try and keep this short, simple. All right, so Typically a honeycomb aluminum panel, typically they come in 1 inch or 2 inch thicknesses. You can get some customized thicknesses. So with this one, for the floor, let's go with 2 inch thickness. And let's reverse the direction and okay. All right, so we have our first part. All right, so now let's create some vertical walls. So let's start with the first vertical wall. So I'm going to double click on the assembly, and I can also insert a 3D part from here instead of using the icon at the bottom. Okay, so we insert a new sheet protector with the new sheet, and let's go ahead and call this outer wall. All right, so let's go ahead and sketch on this plane, the XY plane. Now we want to sketch inside here, so just to double check, double click. Notice it's blue, so now we're going to design inside of this sheet of paper. So on the XY plane, we're going to create a sketch. Let's go ahead and create the outer wall. So I'll do a simple rectangle. Notice how it's snapping to the grid. Hold on to the shift key on the keyboard so it doesn't snap. And let's give this a thickness. Let's go with 1 inch. I think I should have said no on that one. 1 inch. And half of 100 is 50. Okay, so there's our wall. And I'm going to go ahead and hold the shift key. Just guesstimate the length. I'm not going to worry about it just for time. Okay, so now let's go ahead and pad that sketch. And let's go with 60 inches in height. All right, so we have our outer wall. This is called modeling top down. So we're modeling inside the assembly, and we're modeling in context, meaning we're modeling the parts where they actually go with respect to the aircraft coordinate system. In this case, the spacecraft. Okay, now let's do a pattern, circular pattern. So we're going to take this outer wall, and we're going to create an assembly pattern. Okay, so we're going to use the axis that we created earlier to rotate about. We're going to go with a circular. Whoa, made a mistake on this one. Let me clear. I was supposed to pick the Z axis. Let me cancel out and do it over again. I was supposed to pick the wall. Okay, so let's pick the wall. And for rotation, we're going to pick the Z. There it is. The Z axis. And now we have the circular option. We didn't earlier because I chose the axis instead of the Z axis. I chose the whole axis system by mistake. Okay, so now let's increase the number to 6. And let's go ahead and rotate this at 60-degree increments. I'm just going to eyeball it. 659, 60. There it is. Okay, so it generates outer walls. Notice we have the first wall, the original one. Then we have instance 1, 2, 3, 4, 5. I should have labeled this as point 1, and then it would go in order 2, 3, 4, 5, and instance number 6. But that's all right. We can always go in properties and change this. We can always change it in the instance, right? This could be number 2 and so on. Leave it alone. Okay, notice these yellow axes. Okay, so that tells us that this wall is not in context, meaning, hey, it was designed here, but now it's over here, right? We just made copies of the original one. I want you to notice that if we were to move the outer wall out of context, out of its original position, if I move it I want you to notice it turned yellow, right? Let me hit undo, Control Z, goes back. It's back in position. All right, so now let me show you bottom up type of modeling. So I'm going to create a new part and we'll call it the tank, the COPV tank for our fuel, or maybe a pressure tank. Okay, so I'm going to sketch on this vertical and let's go with, okay, there we have it. Let me hit normal and I'm going to cut it in half so I can then rotate it to create our COPV tank without fittings because of time. So let's go ahead and delete and keep half of it. All right, so let's throw in some dimensions. Let's keep this symmetrical about the horizontal. And let's go ahead and give it a dimension. Let's go with the height of, I don't know, 48. 48. And let's increase the radius. I don't know, let's go 24. Nope, too much. Undo. 12. All right, good enough. Let's exit and let's go ahead and rotate to create our tank. 360 degrees, and there's our tank. It's not perfect, should be round at the top. That was my mistake. All right, so we're going to call this the COPV tank. Okay, so now we're going to take this, copy it, and paste it into our assembly. So this is referred to as bottom up. So we went from bottom up to the assembly. Okay, so notice there's no yellow axis, but once we move it into location, use the compass, I'll drop it down here. I'll select the tank, and then I can move it around, as you can see. And I can also rotate by, oh, forgot to select it. You can also rotate by pulling on the arcs, as you can see. All right, and then you can go ahead and name this. So we'll call this Lunar Lander Example. Double click at the top, and once you save, it'll save everything in that binder. Okay, so I hope you enjoyed this video, just to give you a quick idea of how to create an assembly, and in a later video I'll show you how to insert an assembly drawing and how to insert or how to add constraints to an assembly. See you in the next one.